Salam and welcome everyone. Welcome back to my channel. So today we're going to be working on the question on the screen that says the addition of 5.00 grams of a compound to 250 grams of naphthalene lowered the freezing point of the solvent by 0.780. Calculate the molar mass of the compound. So we are asked to determine the molar mass of the compound. But first, we have to reread the question and write out all the parameters as well as highlight the keywords. So we're told the addition of 5 grams of a compound, an unknown compound, we're not given the name of the compound, to 50 grams of naphthalene, lowered the freezing point of the solvent by 0.78. Calculate the molar mass of the compound. So we're going to first of all write out all of our parameters. We're told that the mass of compound. So I'm going to call this compound. So M sub comp, or let me just call this compound X just for ease as we're solving this question. So M sub X is just simply 5.00 grams. And then we're also told the mass of naphthalene. So was the mass of naphthalene. So M sub naph is simply 250 grams. Then we're told that when there was an addition of the compound into the naphthalene, it lowered the freezing point of the solvent. In this case, you're going to be wondering, what is the solvent? Let's not forget, in general chemistry, we're told that solvent is whatever is in a larger quantity in a mixture. So in a situation where you're mixing salt and water together, the solvent is going to be water because you expect the salt water to have a higher quantity of water than salt. So that's an example of solvent, something that has more or the most quantity, and the thing that has the lesser quantity whenever you're just dealing with a binary mixture, meaning mixing two things together like salt and water. The salt will be the solute, it's a lower quantity, while the solvent is just going to be the water. So we know it's naphthalene because 250, of course, is greater than 5. So the mass of naphthalene lowered the freezing point of the solvent by 0.780. So the freezing point is just going to be changed in T sub F, okay, is equal to 0.780 Kelvin. Calculate the molar mass of the compound. So we're told to find the molar mass of compound, or let me just say the molar mass of X is what we're supposed to solve for. Looking at this question and remembering our book from Atkins Physical Chemistry 11th edition, because this is a question from Atkins Physical Chemistry 11th edition, there is a formula that we use to solve questions like this, and this formula is called freezing point depression equation. So this is called freezing point. The formula we're going to use to solve this, freezing point depression equation, which is just simply saying that changing T sub F is equal to K sub F multiplied by B, where the change in T sub F is simply the freezing point depression value that we're given. So, or by how much the temperature changes when the temperature gets lowered. So freezing point depression value, which we're given in this case to be the 0.780 because of the lowering of the freezing point of the solvent after solute was added to it. So that is the value. Then K sub F is just simply the freezing point constant. So freezing point constant of the solvent here. Like I said, the solvent is always going to be a higher quantity, which is just simply going to be the freezing point constant of naphthalene. And then the last thing B is just the molality of the solute. So yeah, so when we look at this question again, we see that we have the change in T sub F. We can determine the K sub F, and it's just the freezing point's constant value of the solvent. Anytime you see solvent in a question, just like we know speed of light to have a constant value, Avogadro's number to be a constant value, we already know that we're not going to have to determine the constant. The constant is always the same thing, like the gas constant to be 8.3145 or 0.082 061, whatever the case is. In this case, it was a constant. And to determine what this constant value is, we look at the Atkins Physical Chemistry 11th edition's resource section of the textbook. It is at the back of the textbook, and you see it, or you can just simply Google it. What is the freezing point constant of the solvent naphthalene? So the value for that, when I look at the Atkins Physical Chemistry 11th edition textbook, K sub F is just simply 6.94 Kelvin kilogram per mole. So that is what that is. And then, of course, we've got B to be the molality of the solute. Yeah, molality of the solute. Now, we don't have the molality of the solute. It wasn't given to us. So normally that's what we're going to solve for since we have two unknown. But there's an issue with that. Some students will determine what the molality is supposed to be, and then they don't know how to get on from there because the question is actually asking us to determine the molar mass of the compound. Now, going forward, I'm going to be doing a lot of algebra. So do take a deep breath and breathe out and try your best to follow. And if you're confused at any point, please just watch the video to the end and rewatch it again. I am doing an advanced algebra. Not advanced, I'm doing a more complex algebra, which you guys are supposed to be able to know how to do by now. But I know that it's algebra still. So I'm going to explain it now. I'm just letting you know that it's not going to be much math beside algebra. So remember from your Gen Chem that B, which is the molality in this particular chapter, is simply the moles of solute. Okay, that's the formula for molality. Moles of solute in mole divided by the mass of solvent in kilograms. In kilograms. That is really just the formula for molality. So if you're asked to find the molality of something, it is simply the mole of the solute divided by the mass of the solvent. Now, when we look at this question, we're asked to determine the molar mass of the compound, but all we have is the moles of the compound or the moles of the solute. We don't have the molar mass of the solute, and we have the mass of the solvent. If we substitute this information as it is into the value of B, we're still not going to get the answer that we're looking for. Now we have to also remember from general chemistry that mole, okay, is simply equal to mass over molar mass. That is how you determine the number of moles of something. Mole is equal to mass over molar mass. So that just simply means when I use this information here, the value for B in this case will simply be the mass, okay, of the solute, okay, divided by molar mass of the solute. All of this information divided by mass of solvent. So that is what is going on here. So that is what is going on here. So now to the algebra part, we see that I explained that I'm going to be thinking of the compound as compound X. So rather than writing comp, I'll be writing XXX. So now the value for B, or what B is simply the moles of solutes. The solute here is the compound X. So that would just be moles is equal to number of moles equals to mass over molar mass. So it's just going to be M sub X. Okay, so the mass of the solute divided by the molar mass of the solute divided by the mass of the solvent. So the mass of the solvent, and the solvent here is naphthalene. So divided by mass of naphthalene. So rewriting the formula, changing T sub F is equal to K sub F multiplied by B, I'll have changing T sub F is equal to K sub F multiplied by B. So I'm going to substitute this information here into B. So changing T sub F is equal to K sub F multiplied by M sub X divided by molar mass sub X divided by mass of naphthalene. So yeah, that is basically what I'm doing here. You see, we know if we go back to our question, we see that we have M sub X. We're given the mass actually of we're given the mass of the compound M sub X to be 5 grams. We're not given the molar mass of the compound, which is what we're trying to solve for over here. Okay. Then we have mass of naphthalene. Let's see if we're given that. We're given the mass of naphthalene to be 250 grams. We're given the change in T sub F to be 0.78 Kelvin. And then lastly, we know the value for K sub F because it is a constant to be 6.94 Kelvin kilogram per mole. Knowing all of this, we can now solve, okay, more algebra. Solve in terms of M sub X. So I'm going to rewrite this equation in that way. So now we're going to be doing the calculation in algebra. So we have changing T sub F, okay, is equal to K sub F multiplied by M sub X divided by MM sub X divided by M sub NAF. So of course, since we're trying to get this to be the subject of formula, we're just going to cross multiply. So we have changing T sub F, okay, multiply the denominator. So that would be M sub naphthalene is equal to K sub F multiplied by M sub X divided by MM sub X. Again, we cross multiply again. So we have changing T sub F, okay, M sub NAF and MM sub X is equal to K sub F multiplied by M sub X. So yeah, so since we're trying to get this to be the in terms of the equation, so that would be M sub X. So sorry, MM sub X is equal to K sub F M sub X divided by changing T sub F multiplied by M sub NAF. So yeah, that's basically it. So that's basically it. We already know what the value for KF is, the value for M sub X is, the value for changing T sub F, and the mass of naphthalene, which we have to make sure is kept in kilograms. So we can just simply solve this question. The K sub F, going back up, is just our value, 6.94 Kelvin kilogram per mole. So that would be M sub X is just 6.94 Kelvin kilogram per mole, okay, multiplied by M sub X, which is just simply the mass of the compound, which we're given at the beginning to be 5.00 grams. I intend to put it in kilograms because I want to make sure all of our units are in kilograms. Since we need the mass of the solvent, mass of naphthalene to be in kilograms, and we already have the Kf value to be in Kelvin kilogram per mole. So I'm going to change this from 5 grams to 5 kilograms. I don't have to show that. It's just simply 5 divided by 1000, or 5 times 10 raised to the power of negative 3 kilograms. So that's the mass of the unknown compound X, divided by the change in T. We know that to be 0.780 Kelvin. It was given to us in the question. Multiplied by the mass of naphthalene, which is that's 250 grams, or 250 times 10 raised to the power of negative 3 kilograms. So multiplied by 250 times 10 raised to the power of negative 3 kilograms. Yeah, that's it. So you cancel out the Kelvin, cancel out the Kelvin, cancel out the kilograms, cancel out the kilograms. Yeah, that's what we have. So we have M sub M X is simply 6.94 times 5 point, or times 5.00 times 10 to the power of negative 3, whatever you want to call it, is just simply, the numerator is just simply going to be 0.0347 divided by 0.780 multiplied by 250 times 10 to the power of negative 3. That's just 0.195. So kilogram here divided by mole, so kilogram per mole. So far, we input this information here into our calculator. We end up getting the molar mass of X is just simply 0.17794.872. So we have found the molar mass of the compound X, kilogram per mole. But then there are just two things that we have to take note in this answer. First of all, usually molar mass is usually found in gram per mole. So I am going to have to change this from kilogram per mole to gram per mole. So I'm just going to multiply this by 1000. So by 1000 grams, by 1 kilograms. So we cancel out the kilograms. So we're just going to have this now in gram per mole. So the molar mass of X, simply 0.17794.872 times 1000 is now 177.949 gram per mole. And that's basically the answer to our question. But then again, we're scientists, we're chemists, we have to put our work in the proper number of significant figures. So when we go back up, we have to see what is the lowest number of significant figures given to us in the question that was used to solve the question. So going back, looking at the numerical values, we've got 5.00 in 3 sig figs. We've got 250 in 3 sig figs, and we've got 0.780 in 3 sig figs. So our final answer for the molar mass of the unknown compound X is going to be in 3 sig figs. So that's just going to be the molar mass, okay, of X or of the compound is simply 178 gram per mole. And that is basically the answer to this question. So for those of you who may be confused, the X, I just use that to make things easier for you guys. You can decide to use another variable, whether it's X, whether it's just M sub C to denote the compound. I just decided to do it this way. So yeah, if you're confused by what I've done, please rewatch this video again. If you have any questions, make sure you put it in the comment section. If you also have suggestions, concerns, opinions, also put it in the comment section. I also wanted to mention that if you're a student who is trying to succeed in all your STEM related courses, whether you're in middle school, high school, or university, I'm the tutor for you. I help students to be the best version of themselves in academia by my way of tutoring and mentorship of students. So yeah, if you would want me to be your personal tutor, I tutor other STEM related courses from differential equations to organic chemistry to general chemistry to physical chemistry to all the calculus. Yeah, make sure you email me. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.